Hey everybody, can you hear me okay? All right, well, thanks for joining my talk here. It's the merits of offline first. And so let me caveat this by saying that I've never talked at anything before. This is maybe the second time I've ever used PowerPoint. So bear with me here. Hopefully there aren't a lot of typos in here, and hearing my own voice in a microphone is very odd. And I just realized that all of this is being recorded, so that's great. But if you had a chance yesterday to see Ignacio Fuentes' talk, it was about how you can use offline with Kinbei, and I know we were talking earlier about that. And so this is, we were talking about it earlier before the conference started, and I think this talk should serve as hopefully a decent complement to what he discussed. He really went through, how can you use Kinbei to enable your offline stories? And what I want to talk about today is why you want to do that and why you should maybe change the way you think to think more offline first and not use it as just a complementary tool, but a primary goal in your app development. So again, the talk is called Merits of Offline First, and it's an offline first app development approach. And so it'll be a nice discussion, and hopefully we have some time during the talk if you have any questions, we can just have a chat about different things that you might have concerns or interests about. So at one point in time, for a minute and a half when I was in high school, I flirted with the idea of being a journalist and then quickly discarded that idea. But the way I'm going to approach this talk is basically trying to answer those 6 classic questions that I think people in journalism still try to answer, which is who, what, when, where, why, and how. So first we'll talk about who is giving this talk. That'll be me. And then we're going to talk about what offline first is. Then we'll talk a little bit about when does it make sense to develop with an offline first mentality. We'll talk about where in terms of broad use cases that I think benefit very well from an offline first approach. Then we'll talk about why you should actually have this type of mindset, in my opinion. And lastly, once we have answered all of those questions, we'll talk about how you actually go about this. So first, who? That would be me. So my name is Vinay. I work for Progress Kinbei, for the Kinbei engineering team, and specifically I work for the SDK team. And so in case you're not as familiar with Kinbei, it's a platform on which you can build apps, mobile, web, and build out whole solutions. And the SDK team in particular interfaces with the Kinbei platform in the back end using native technologies. So if you're writing an iOS app, we have a Swift SDK. If you're writing a native Android app, we have an Android SDK, cross-platform, native script, so on and so forth. And so that's the team that I work on. And what's interesting about that team is that it's all remote. So everybody that's on the team doesn't work out of the Boston office, which is where we're based. And we span 10 time zones. Maybe that's not the exact way to put it, but we basically have a 10-hour time gap between the person who's furthest east and furthest west in our entire team. To make matters more interesting, as a result, I am a world traveler as well. So because we're completely remote, I have the ability to kind of work from various places in the world and use that as an opportunity to travel and explore. So I travel around and kind of set up shop in a place for a month, maybe 2, and work from there, and then use that opportunity to go see things like Angkor Wat over a weekend. And the reason I bring this up is that because I am on the move a lot, I depend a lot on good mobile applications and good user experiences when it comes to mobility, because I'm mobile all the time. A great example for this is Slack. Slack for me is an indispensable tool for me to be able to get my job done. The way that we use it to just asynchronously communicate across everybody who spans all these time zones, and to be able to communicate that information in a clean manner is very important to us. And Slack has a great experience when it comes to offline. So I don't know if you guys are familiar with using Slack, but a lot of times, even if you don't have network connectivity, you will still have an experience where you can actually still go through, read through different channels that you have, get some information, and this isn't contrary to other apps that I've used in the past. So in particular, there was this one app that I was using when I was traveling that was a lounge finder. So since I travel a lot, it helps me to go to an airport lounge and do some work if I have a long layover. And this app helps me find lounges that I can actually get access to. Now, I remember one time, opened up the app, and I'd already had the page set for where this lounge was in the airport, how I get there. And as soon as I turned my phone back on, or well, turned it off of airplane mode, I didn't have any network connectivity, and I brought the app back from the background, and all of a sudden, that page I had was just gone, and it was right back to like a starting page, but there was nothing there. It was just a blank slate, and I just lost all the information that I really needed, and I should have taken a screenshot of it, but I didn't think that I would have to, and so that kind of incensed me a little bit, and that's why I'm very keen and interested in creating good offline experiences for apps. Because for me, it's indispensable. As I move around through various places, I have various network conditions that I have to deal with. And that could be different network speeds. It could be network dropping in and out. And it could be my cellular provider just not having any service in Peru, for instance. And so that is part of the motivation of why I want to talk about offline and why you might want to consider an offline first strategy. So to that point, we should talk about what offline is. Now, back in the day, in the early days of the interwebs, we basically had what I would call network-first ways of creating apps. Traditionally, mobile applications were running on devices that were not that powerful. And so, effectively, it was kind of like a thin client. You would use it to get information, and you would, surface it on the phone, but you really couldn't interact with it all that much over there. It kind of followed a bit more of a client-server model. And I think that makes sense because that's where we were kind of coming from in the past. And so that made sense when we had smartphones that were not that powerful. But as time has kind of gone on and following Moore's Law and whatnot, the mobile landscape has really changed a lot, where the definition of a mobile device has changed. You no longer have these smartphones that were pre-iPhone. Now you have these iPhones that were, I believe there's a quote out there that says, an iPhone that came out several years ago was more powerful than, the computers they used to land on the moon. So there's a lot of power now you have in mobile devices, and the nature of mobile devices is also changing. We're not even thinking about just phones, but also tablets are very popular as you move around, not just something you kind of use in your own house, and even laptops. I remember I've seen police automobiles with huge tough books that are just mounted into the car itself. And so the nature of the type of device we use for mobility is changing. And with that, we have greater power and greater storage capacity on the device itself, which means that if you want to create a better user experience and a more robust app, you can take advantage of the compute power and the storage that you have on your devices. And that's a lot of where offline capabilities kind of come in. Offline capabilities just speak to the idea that you can offload some of this processing onto your client devices at the edge, and you can also utilize storage for persistence. And as those have been introduced into app development and they've matured, they've mostly been added as in my mind, a way to supplement an existing app or supplement a network-first mentality. So the assumption is always that I can get to the network and I can perform all my operations there. But when I have an app that works offline, it's just kind of bolted on as a way to say, okay, well, what can I do to make my app a little bit more robust or a little bit more performant? But it's still thinking with the network in its foremost sense when you come to actually trying to figure out what your workflow is and how your user's going to consume it. And so I think because we have all of these capabilities now that live on the device, what we want to do is we want to maybe change the way that we think about how we go about app development. So instead of using offline capabilities as a way to supplement our network-first strategy to building apps, what I'm advocating here is an offline-first approach. And so offline-first, in a very colloquial way, is a development approach that you can use to build apps that you expect to work regardless of whether or not you have a network connection. And I think if you approach app development in that way, you're going to be able to create a better user experience, one that is not dependent on how your network is performing. I think there's an analogy that you can probably draw here between this mobile-first approach to app development, which talks a lot about how you want to make sure that you're developing for your smallest devices, and then consider that your device of least power, and then you kind of work from there. And that way, you're not developing without thinking about the lowest common denominator. And so in here, this is kind of an add-on to that, where you start to think about development where you're not looking at having to have that network connection in order for your app to work. Imagine that you don't, making sure that your use cases are all pretty clean if you happen to not have network for either a small amount of time or a large amount of time. So before I go into the next slide, does anybody have any questions about how I've defined offline first here? It makes sense to everybody? I think it's a pretty standard concept that's just kind of highlighting it a little bit. So now we'll talk about a little bit about when we want to use offline first. And essentially, the idea behind offline first is that you don't assume or require a constant network connection. So you want to make sure that when you're building your apps, you don't want to assume that you can always get to data in the back end. Sometimes that may be true for a small amount of time because you might have a network blip. Sometimes that might hold true because you just don't have a cellular connection at all, or you want to work with Wi-Fi, or you have a type of device that only works on Wi-Fi. And so offline first is just assuming that you don't have that. So when you want to use it is when you can't rely on having a network connection all the time. And that's not always the case, but I think when it comes to mobile devices, it's more and more prevalent. And even more so than not having a network connection is just the variance in connection speed and quality. So with offline first, we also consider data to be something that you work with on the device. It's not just that it's data that kind of sits there in a caching kind of sense, but you're actually looking at working with your data as if there is no network. Everything resides on your device, and this is how you want to approach how you build your apps and how you build your experiences. So offline first, again, assume that everything you need is on the device. And I think that if you make that shift in the way that you start to develop apps, you can actually guard against edge use cases where you potentially run into not having a network connection and then end up with a UI that's not hydrated well, or an error condition that you don't necessarily anticipate. So I think if you always work with the assumption that you're trying to work with data offline, it will guard against some of those cases. And another way to kind of perceive offline first, which is another approach, is you choose when you want to sync data to and from the server. So your device can now be a view into the data that you want to work with, whether that's an entire set of data, whether it's a smaller set of data. You can take this data, work with it on the device, and then you can be more prescriptive about how you interact with your network. And that can lead to just more judicious use of cellular data, maybe better use of battery life, things of that sort. So one thing I want to talk about now is, now that we've kind of defined offline first and kind of motivated a little bit, I want to talk about where you would use offline first use cases in a very broad sense. The idea behind this is to kind of highlight a few different use cases, and potentially if you're creating an app or have an existing app that you want to adapt to be more offline ready and offline first, you can see whether or not your app kind of falls into one of these three buckets. And these buckets are not mutually exclusive, as we'll see on the next slide. So the three broad use cases that I'm talking about here, we talk about internally at Convey as field force use cases. This term I made up, so I don't know if that's how everybody else talks about it, but sparse updates, and then large data sets. So let's go through each of these one by one, and we'll talk a little bit about where these use cases benefit from an offline first strategy and how they kind of overlap. So in the field force use case, what I'm talking about here is apps that basically are running for employees, let's say, that are distributed across a larger geographic location. It could be service workers who have to go out and service requests in the field for a utility company. Or it could be traveling salespeople who want to go out to customers that are sitting out there at various locations in the field instead of having them come to them. And when you have these distributed locations, you can't necessarily count on a consistent network. Now, maybe that's not the case as much here in the States, but if you're thinking more globally and you're thinking about a workforce that maybe works in Asia or in South America, what I've found personally in my travels there is that network consistency can be pretty tough. And that doesn't even include power outages or brownouts. And so being able to be resilient to some of those fluctuations, I think, is pretty important for the field force use case. And so what we do here is if you plan to work offline most of the time, then you don't have to necessarily worry about having that network connection. You can do all the work that you need to do and then potentially choose to sync up when you know you're in a better network situation. It could be back at the hotel with Wi-Fi, and you can sync up then. Another example is sparse updates. And so let me give an example of what I'm talking about here. We have a customer that is in these, that basically has data sensors, and they create a lot of time series data. And they collect a lot of this information, and what they currently do is they immediately send this information up. Like maybe they collect it themselves in memory, and then every minute or so they'll kind of, send it up to the Kimbay backend in order for storage. And they need that data for trending, for analysis, and potentially some machine learning as well. But the nature of their data and what they want to do, in my opinion, is not something that they need to have updated in the backend in real time. These are edge computers that are producing this information that need to be sent up and centrally stored, and then you can create some information and some graphs on it. But it's not anything that mingles with other devices, and it's not information that has to be continuously sent up. And so if you have an offline first approach to this, you can potentially save a lot of cost with network calls and gain better performance as well. So instead of continuously pinging the network with more information, maybe you store information for a set amount of time, a minute, an hour, so on and so forth, maybe even more. And then you can take that information, you could possibly even on the device, process some of it to consolidate it a bit more and make it less verbose. And then you can send that up to the server, and that can actually help you out with some cost in terms of network calls and in terms of battery power. And then the third case I want to talk about is large data sets. So this kind of spills a little bit into the traveling salesman idea. We have had customers and prospects in the past that have like a huge catalog of information for SKUs, for items that they want to sell. And they'll go out into the field to various suppliers and try to either refresh them, sell them more stuff. And they work with a large data set, a large catalog of information. What we found with some of these customers is that they don't necessarily need to work with all of the information that they have, but they have a subset that they need to work with. It's not information that has a lot of conflict with what other people work with. So they can bring all that information down onto their laptop or tablet and go around and be able to, like, if they need to query and need to like work with the customer to try to figure out what they exactly want, it's a lot easier to work with that data when it's sitting on your device itself. And that especially holds true the larger you get in terms of your data sizes. And so that is the idea behind large data sets, where you can get more performance when your data is just sitting closer to where you actually need it, which is, it generally holds true, not always. So these are like the three use cases that I've kind of defined here, and a lot of them kind of commingle. So yeah, go ahead. That's a very fair question. I think that it's hard to give a bucket answer for all that, because as you said, there are various devices that have different capabilities. For example, one of the cases I'm thinking of a prospect that we had with these huge data sets, like millions of records that they're bringing down onto their devices, they were using Surface tablets. And so device size and power was not really much of a concern for them. But if they also had to have the same people maybe working on an iPhone or a Samsung phone, then certainly size would be a problem. And I think that maybe in those cases, depending on the type of device you have, you could more judiciously choose what you filter when you're pulling down data. So you're still syncing data, but you might have to be a little bit more cautious about how much you actually pull down. And then in there, maybe it's a balance of network calls in order to get other data if you need it versus not. So it's almost like a paging strategy. Yeah, sure. I mean, I think a lot of it depends on kind of your use case and how much you want to be able to pull down. So, for example, one of the use cases I'm thinking of, they have a large data set, like 12 million records, 15 million records. Like it's pretty sizable, and it's the type of data set that it's not necessary for one salesperson in this case to have all that information on their device. And so there's a subset maybe for the products that they sell, and they're able to kind of filter off of that and only pull those products down, which helps them a little bit when it comes to storage constraints and whatnot. So you probably have to get a little bit more creative with some of the filtering there, and then some of it might just be, well, how can we pull down information that we think will be more readily used by that particular contractor, and then have to maybe set up a set of queries and then maybe have to recache depending on what they need. So
similarly, how Google
yeah.
uses the Google Maps or whatnot.
Yep.
You can cache locally the maps.
Sure, the offline maps, yep. Yeah, sure, absolutely. And we'll talk about this a little bit when I get to kind of the how section. We'll talk a little bit more generally about how you can accomplish some of these use cases, but then we'll specifically talk about Kinbay and how, like, within the Kinbay architecture, you can actually potentially just pull down a subset of data and try to work with that and not use as many network calls. Because the alternative, right, is just to go to the network all the time, and that becomes very costly. So yeah, and maybe some of that can be dependent on device type. Maybe within your app, you can try to determine what class of device you have, and based off of that, decide how much you're willing to pull down on the device itself. Yeah, it's a great question. Remind me when we get to the how section, and maybe we can revisit it when we talk about Kinbay. Great. Any other questions at this time about where or different use cases in general? Okay. So let's get back to offline first. We've kind of defined it. We've talked about where it can potentially be used. And so now I want to talk a little bit about why you want to think offline first instead of just offline as an add-on, or network first in general. And the first point I want to bring up is robustness. When you're talking about an app that only connects out to the network, you are then susceptible to the network. And as we were talking about before, that can vary a lot in its consistency. It can vary a lot in its speed. And if you're not thinking in an offline first manner, you're kind of pushing a lot of that variability onto the user experience itself. And I think that from creating a good user experience, and we'll get to that in a little bit, we want to try to shield some of this information and some of these variances from the user itself and try to provide a more seamless experience. So with that, the question I think to ask yourself around this is, if you're building an app from the ground up, why not do it with more robustness in mind instead of just the easiest, best green path over to how you actually want to get your data to your device? Next is performance. And the first statement that I have up here is pretty obvious, which is the closer you are to the data, the faster it is to access. I don't know if you've ever seen that chart that they talk about with memory and how your speeds of access from registers to L1 cache, L2 cache, to secondary memory, and then to storage, all starts to vary quite a bit. And as you move further and further away from the chip, it's kind of a similar case, with network data itself. It depends on the type of network connection you have, how far away it is geographically, and some things you can't control with that because it varies so much. It's a distributed system by nature. But if we can guard against that by having an offline first approach to how you develop your code, it becomes a bit more robust, as we were talking about before, and also you can gain some performance by not just assuming that you're always going to be able to get out to the network. So the question here to kind of maybe ask as you're developing an application is, how fresh do you need the data that you have on your device to be? And instead of just saying, well, I always want the latest and greatest, sometimes that makes sense. In the talk yesterday with Ignacio, there was a gentleman who brought up the use case of a sports app. And in that sports app, you want to get live score updates. Now, live score updates don't do you a lot of good if you're half an hour late on them, and it's like 45-minute halves or something like that. So that's maybe not the best use case for trying to store data offline and just use it offline, but certainly there are probably other components to that type of a sports app where you don't necessarily need to always get the latest and greatest data from the network. And so it's just thinking about how fresh do you need that data to be in that use case, so that way you don't unnecessarily use the network. And the third point, which I alluded to a little bit earlier, is a consistent user experience. So, in my opinion, a user should not really be concerned or even aware of where data is necessarily coming from. They're just trying to use the app. They want a resilient experience. They don't want to think about whether or not they're in an elevator or in a tunnel or in a low network coverage area. Now, sometimes you can't necessarily hide that from a user, but if you start to build with an offline first mentality, the idea is that you don't have to expose the user to some of the pains that you can potentially run across and that you're trying to code against when you're building your app. So again, how can you provide a more seamless experience in your user interface and your user experience in the face of varying conditions? It's the same as kind of mobile first, where you have variable device sizes, and in here it's about variable network conditions. So ultimately, in the end, it's a long way of, I guess, saying that the goal of an offline first app is to be network resilient. So just like a mobile first app is trying to be resilient to the different types of devices that you might have and screen sizes that you have in order to give a certain user experience to your users, an offline first app is meant to be network resilient. In face of different changes that you have in your network, your experience should be consistent and great for your users. So what I'm saying based off of this is, as the slide says, instead of an offline strategy that complements an existing network first strategy, perhaps we should start thinking about building apps under the assumption that they're offline. And if you approach app development in that manner, I think it will help guard against some of these conditions and ultimately provide a more consistent and therefore a better experience for your users. Does anybody have any questions about that statement or contend it? It all kind of makes sense, right? If you have the capabilities to use offline storage and computing power, why not try to use it? And then this is just taking it one step further and saying you should always use it, and then maybe think about like why you want to actually access the network. So moving on to how. So we talked about the who, what, when, where, and why, and hopefully I've done a little bit of work here to motivate offline first as an approach. So now let's talk a little bit about how you actually do it. So there's a couple of different approaches that I know of in terms of trying to implement offline and then therefore being able to provide a more offline first experience. So one is caching of data, which is a pretty standard approach. And then another one is called manual replication. And we'll go through each of these a little bit. Caching is what we call sometimes in Convey when we talk about things as the elevator scenario. So I'm using Slack. I'm upstairs at my office and I'm going down for lunch. I'm talking to somebody and talking to a colleague, maybe trying to figure out if they want to join me for lunch, and I get into an elevator. Should my app just suddenly stop working? Or maybe I'm not even talking to somebody, I'm actually just like trying to read some information that was just presented in a channel about a project that I'm working on. If I step into the elevator and suddenly have no connection, Slack does a really good job of telling you that you have no connection, but then the user interface is still very responsive. And so that's kind of our elevator use case where we talk about where you have these blips in network connectivity. How do you guard against that? And how can you make sure that your users don't feel the pain of varying networks? And so caching in general, we really talk about taking information that is, from the source of truth, which is usually the back end, and having some sort of subset based on some filtering on your device itself. And mostly this is talked about in the context of reads to make sure that your UI just stays very responsive. But it can also, I think, maybe account for writes as well. And we'll talk a little bit about that when we talk about Convey. The pro for this is it offers robustness in network variants, as we were talking about before. But the con of this is that it assumes that networks are generally available and not necessarily not available all the time. So it works in the elevator use case, but then the general assumption with using this type of strategy is that you are going to be connected to the network for the most part, which may work for your use case, but it's worth considering other options. The other one's called manual replication. And so this kind of comes to the point that we were talking about a little bit earlier, where you have a subset of the data that you want to store on the device to be able to work with. And the pro of that is that all your data operations are done locally. So again, it's that abstraction where you think of, I'm just writing data to and from some store. That store may exist on the device. It may exist in the network, but you don't want to necessarily depend on being able to get out there. You just want to make all your operations such that they all work locally and everything works as is. And then you can choose when you want to actually sync up data. So in the case of a traveling salesman, for example, you can have all this information for SKUs and take orders, and all of your orders can be compiled locally online. When you get back at the end of the day, you can sync up and push all of those orders up to a central server, and they can get processed. And that's one way of doing things. And in that use case, it probably makes a lot of sense. The con with this is, well, I'm sure there are plenty of cons. One that I want to draw attention to is conflict resolution. So depending on your use case, you may run across data that is being collaborated on or worked on by multiple people. And in this type of scenario where you have manual replication, you may end up with conflicts. And you have to have a strategy around conflict resolution. I'll talk a little bit about what we try to prescribe at Convey But that is something that you have to consider when you have this type of manual replication paradigm. So speaking of that, then I want to talk a little bit about the Kinbay and the Kinbay data store. And this branches a little bit off of what Nacho was talking about yesterday. So for those of you that were not there, the Kinbay data store on the SDK side tries to, I guess, define how you interact with offline data in terms of store types. So it's almost like a way to package up different read and write policies. And so we have a couple of different store types that work with offline. One is a new data store type that we're introducing called auto. And what auto does is it basically tries to favor the network. So it's almost a way of thinking of things as like a network preferred. So we try to get to the network first, but we offer robustness by saying if you can't get to the network for connectivity issues and whatnot, we'll be able to fall back to data that you have on the device and offer that up to your UI. So that way you don't have to constantly code against error conditions that you get if you just happen to not be able to hit the network, and you can at least hydrate your UI with some information. And this, this applies a lot to the elevator use case I think that we were talking about earlier. And if you find that your app is best suited for that type of usage, then maybe the auto store is for you. Now, the sync store, on the other hand, is kind of our way of trying to implement the manual replication model of offline first. So we have all of these operations that you perform, and when they were performed, it's the same exact network call that you would make through our APIs to go to the Kinbay backend, but instead they all just operate locally on whatever offline data store you have. And then there are a few different methods, push, pull, and sync semantics that we have within the SDK to allow your syncing up with the Kinbay backend as is. So you manually decide when you want to call these. You could tie them potentially to different events that happen for maybe online and offline detection that you may have in your app, or you can just choose based on certain UI triggers that a user might go through to actually decide when you want to push and pull. For example, what Nacho was showing in his demo earlier yesterday, just pulling down, which is a pretty standard gesture that you would use in a mobile app. Any questions to this point? So going back to what you were talking about before, if you have, let's say, a sync store and you're trying to do this manual replication route, you can choose to pull down, through a filter. Like if you were trying to pull a certain amount of data down, you don't have to pull all of that data down. You can apply a query to be applied at the back end and say, I want all the data that kind of fits, this filter that I'm passing back. And it could be a filter based on a particular contractor maybe. And in the back end, you can say, well, this contractor has access to these sets of records, and maybe that reduces the scope of the data that's kind of brought down. Or it could be time-based. So maybe there's a timestamp or something that exists in your collection, and maybe you could filter off of that to get the last end results or the first end results, something like that. Does that make sense?
Yeah. Would you be able to set it up for giving the user the ability to set the file size that they're willing to download to their computers or their device?
Oh, I see. So are you talking about like data in terms of like different collections, or are you talking about like physical files?
Collections. So like,
okay.
Take example with like Maps.
Yeah.
You can zoom out and make the file size larger.
Right.
Similarly, we have like a local data set of companies that work in this area. Download them, but it
I gotcha. Yep.
You want to go, 50-mile radius in, 50 minutes.
Mm-hmm.
If you want to go 100 miles in 100 minutes.
Yeah.
File download. Would you be able to set something up as part of like allowing them to download based on a file size set?
We don't have a way currently of specifying, size in terms of like megabytes. We could do it in terms of, potentially entity size. So you can like limit the amount of entities you pull down by a certain amount. And, then I guess that would be up to the user or the app developer to understand their entity, how wide is their entity, or narrow. It could be a very small entity, in which case you can pull down a lot more records, or it could be very wide, and you decide based off of that, I don't want to pull down as many. So we can do it on a per entity basis and that count, but not necessarily translating what the size of that entity is to megabytes, and then saying we want to cap it at a certain total size. Yeah, but there are probably ways to solution around that. It's an interesting question. I'll have to think about it a little bit more. But there might be ways to kind of provide some solution around that to maybe say like, well, an entity in general occupies X amount of kilobytes and maybe do some multiplication there. Okay, great. Yeah, sure. Any other questions at this time about the who, what, when, where, why, and how of offline files? Okay. So, I think the main takeaway I want to have here that I want to mention is I think that offline first is really, this has been more of a philosophical kind of discussion or high level discussion. And what I think the offline first mentality is about a paradigm shift that you make in your mind to say, I'm not going to think of offline as something that I can add to ameliorate my app, to make it more robust or to make it more a better user experience by just kind of adding it on. It's an approach you take from the outset. And so what I think is I think of offline access as something that shouldn't just be added when it's convenient or if it's something that you're comfortable with, but it's more thinking about like, when do I not want to use offline access? I think if you approach it from that standpoint, it becomes a lot more about when you actually have to use the network and not just using it because it's easily accessible or that's what just you're comfortable with. And I think if you start to ask yourself that question as you go into a deeper app development, I think you'll more likely than not end up with a more robust user experience. So that's more or less the end of my prepared remarks. I just want to share one quick anecdote. When I was at the welcome party at the beginning of this conference, I was sitting down at the table with a few people I'd never met before. And we were talking about how, I'm from originally the New England area, grew up, born and bred in New England, and we're based out of Boston, Convey. And somebody was telling me that except for the word hockey, I really don't have a Boston accent. Is that something that the room agrees with? So I thought, well, okay. Well, then maybe I should attempt a Boston accent here. So let me close out my remarks by saying, by paraphrasing, but really kind of butchering another famous Bostonian's very famous quote as it pertains to offline and say, ask not what your user's network can do for you, but what you can do for your users offline. That is my best attempt at a Boston accent. Again, I have forgotten that all of this is recorded, and so I'm never going to live this down. But, thank you very much. I appreciate you guys, letting me spew up here for a little while about offline. I hope it gave you a different way of kind of thinking about app development, just, some food for thought. If you have any questions, you can ask them now. We can talk later. And what I would encourage is also to attend a talk given by Mike Salinger, who's actually sitting in the back over here, Convey Engineering, and he's going to talk about best practices for modern app architectures. And I think that is, it's very valuable. I think that thinking about things in an offline manner is probably part of that, but I think he's going to deep dive into a lot of different things regarding how you want to go about building your apps. This is one slice of that pie. I think hopefully he'll give you a much deeper dive into other components of how you build greater apps. And so with that, I want to say thank you very much. If you want to build out better apps and online apps, Convey can help you out with that. Thanks very much. Yeah.
You talked about being able to pull your data down by defining queries.
Sure.
So, for example, if I want to pull customers for a specific salesman. So, are those queries stored on the individual device so that it knows this is salesman XYZ, so only pull his customers and those types of things? Or where are those queries actually stored?
It's entirely, to a certain extent, I think it might be up to you. Like you could set it up like such that it's something that's built into your app, and maybe it's like something that you expose out through a UI. So maybe it's when a particular user logs in, that user has an ID attached to them, and when you have that user, in the context of your app, you have the information you need to maybe query. So now you have that user ID, and then you can query it out of there. Another way you could potentially do it is you could set up queries in a collection, and maybe pull down a certain collection that's based on a particular user, and then end up with a set of queries that you can use to call backend. So I think there's a lot of flexibility in that way. Kind of depends on your use case. Yes, sir.
How secure is the data that's pulled down into the apps as far as like, are you able to rip the data out of the application once it's down on the device?
Ultimately, in the end, this is an interesting question. In the end, my opinion when it comes to mobile devices is that in the end, you don't have total control over the device and some of the permissions around that. So, if we're working with a SQLite database, for example, in some of our SDKs, even though, we can encrypt that data, but, somebody can potentially just go in, get root access to that device and rip that data out. But we try to provide guards if somebody opts into them for doing some levels of encryption. Like all of our data transfer is done, through HTTPS, and data can be encrypted at rest on the device itself. But in terms of actually accessing that information, yeah, it's definitely possible. What you can do with it, I'm not sure.
Since a lot of these devices that work with the
Mhm.
have a lot of applications that are available on the devices, is one of the items that you can do is a root check with many devices, such as like some of these pay apps and whatnot,
Mhm.
require that the device can't.
Oh, interesting. From a permissions perspective, we don't necessarily guard for that within the SDK itself. That's something that I think gets handled. It can get handled at the app level. So we don't do anything to necessarily prevent that. But just being a library that you kind of add into your app, some of those levels of controls are not something that we control or prescribe at our level. Like, are you talking about maybe from an Android perspective, like something you can add in the manifest? Yeah.
Yeah, just checking, doing like a check, like like I was mentioning,
Mhm.
like some of these credit card apps or
Yep.
whatnot, or pay apps require that the device can't be free in order to use the app, and it's proven that you can't install the app or run the app.
Gotcha. Yeah, we don't have any of those built into the SDK itself, but I mean, it's an interesting thing. Maybe we can talk a little bit about it offline to try to figure out if there's, maybe a use case where we can include at least an ability to do some checks in the device itself. If there's like some native code that we can call to say, is the device rooted? And maybe you want to add some code, like make a call into Convey and say, well, if I have this set, I want you to check every single time if we have the appropriate permissions in order to serve up some data. It's not something that I've thought about or we've talked about that much in general, but it's something worth considering. But we don't have it right now.
Right.
Okay.
That's fine.
Any other questions right now? Okay, I think we're right at a time, 11:45. So thanks again for your time and attention, and enjoy lunch. I'll see you there in a bit.